Hello, this is Connor. Today I wanted to talk about a certain scene in the 2015 movie Tracers. I am going to judge the jumps across the garage near the beginning of the movie from a physics standpoint. But before we start, let's take a look at the scene we will be talking about today. Seems pretty impressive, huh? Is it really possible, though? First, we need to look into how large the jump actually was. How many levels of the garage did our protagonist Cam go down? There is a hint further into the scene. Let's take a look. If you take a look, you can see that the man is on the same level of the landing point. And if you count, you can see that there is one level directly above him and one more level after that, making 2 levels total. How much space is there between each floor? According to Gibson Truck World, floor-to-floor heights in parking garages typically range from 10 to 12 feet. Due to the garage appearing to be smaller than most, we will assume 10 feet. If we convert that into meters, we can see that there is about 3 meters of height between each floor, and since Cam jumped down 2 floors, we can double that height, and his total loss of altitude was about 6 meters. Another thing we need to know is how large the gap was. At the end of the clip, we could see that there was a car elevator connecting the 2 sides of the garage. How large are car elevators? There are multiple different models, but let's take a look at the dimensions of some elevators from the manufacturer Automobile Elevator. Their large-size elevator is 240 inches in length, or about 6.1 meters. Now that we know how large a jump is, we then need to know how fast Cam needed to go to make the jump. We can find it by using the formula v of x is equal to d over t. V of x is the horizontal velocity in meters per second, d is the distance in meters, and t is the time in seconds. We already know that the distance is 6.1 meters, but we still need to know how long it took. At first glance, that may seem easy, just time it with timestamps, right? However, we can't forget that epic moments like this are often shown in slow motion, so timestamps are likely not accurate. How can we get the accurate time? In physics, there are kinematic equations to help us out. We are going to use the height to find the time. The best equation for that is delta y equals v of I times t plus half of g times t squared. Whew, that is a long one, huh? Delta y is the change in altitude in meters, v of I is the initial velocity, t is the time in seconds, and g is the acceleration of gravity in meters per second squared. We already know that the change in height is 6 meters. Cam was running on flat ground and therefore wasn't falling at first, so the initial velocity is 0. What about the acceleration of gravity, though? Well, on Earth, it's about 9.8 meters per second squared. Anything times 0 is 0, so we can cancel out the first term on the right side. So we end up with 6 is equal to half of 9.8 times the time squared. Half of 9.8 is 4.9. To get t by itself, we first need to divide both sides by 4.9, which gives us 1.22 equals t squared. Then we square root both sides and we see that the jump took about 1.1 seconds. Now let's plug that into our first equation here. How fast do you need to go to travel 6.1 meters in 1.1 seconds? If we divide 6.1 by 1.1, we can see that to make the jump, Cam would have to run at least 5.5 meters per second to make the jump. But can humans really go that fast? How fast can a human actually run? According to Marathon Handbook, The average sprinting speed of men is 31.4 kilometers per hour. We want to convert that to meters per second. There are 1,000 meters in a kilometer and 3,600 seconds in an hour. To convert, we can simply multiply 31.4 by 1,000 over 3,600, and we get 8.72 meters per second, which is significantly faster than the 5.5 meter per second threshold. So it is safe to say that the jump is possible.